Here's a video review of 218 in case you find that useful. So the first thing you're going to have to do is use appropriate vocabulary. So if I wanted to find the x-intercepts, I'm just looking at the points where it crosses the x-axis, and I need to write them as a coordinate. So -5, 0. The next one looks like 1, 0 and 3, 0. So those are my three x-intercepts. My y-intercept is where does the graph cross the y-axis? It looks like we're counting by fives on the y-axis. So it looks like this is 0, 10. The coordinates of the local minimum. So the overall minimum is all the way down here. It keeps going down to negative infinity. But this is considered a local minimum because it's a point where there's a bottom of the graph and it changes direction, but it's not all the way down at the minimum. So this coordinate would be 2, negative, we said we're counting by fives, right? So 2, -5. Find the maximum of the function if the graph continues forever. So like I said, it's continuing forever. The local maximum would be positive infinity. That's different than writing all real numbers. We write all real numbers when we're talking about the domain. We write positive infinity as the y values go to a million, billion, infinity. How many turning points? So there's 2 turning points on the graph. So it's wherever the graph goes from increasing to decreasing or decreasing to increasing. F of 2 means that if you had a function like x squared plus 3x, you would plug the 2 in for all the x values. Because we don't have a function, we're going to look at 2 on the graph. So when x is 2, what is the y value? And we already said that y value was -5. So f of 2, when we plug in 2, our output is -5. So the answer is -5. The parent function, so what parent function looks like this graph? Parent functions are like absolute value, square root. So this would be a cubic or a cube function, right? X cubed. So between -5 and -3 on the x-axis is the function increasing or decreasing. So here's -5, here's -3. That graph looks like it's increasing. And then what about between -1 and 1 on the x-axis? So at -1, we're here, +1, we're here. That looks like it's decreasing. So as you read the graph from left to right, it's increasing and then it's decreasing. All right, so graphing those parent functions with transformations and identifying the domain and range. So in this function, we're talking about absolute value. It has not moved left or right, but it's been moved up 4. So my vertex is at 0, 4. And a absolute value function is a V-shaped graph that usually has a slope of 1 and a slope of -1. This is going to be flipped upside down, and it has a slope of 3. So down 3 over 1, down 3 over 1, down 3 over 1, down 3 over 1. So V shape is linear, so it should come to a point, right? It's not a parabola, it's an absolute value function. All real numbers, because the graph is pushing out from left to right. But when I look up and down on the y-axis, the highest that I can go is to 4. So all the y values are less than or equal to 4. In number 11, I'm going left 1, because a plus inside the function means you're going left. And I'm going down 4 because outside the function, negative signifies down. So -1, -4 is the vertex or the starting point of this function. This is a square root graph. So the parent function, I'm going to graph up here, is 0, 0 because the square root of 0 is 0, 1, 1 because the square root of 1 is 1, 4, 2 because the square root of 4 is 2, and 9, 3 because the square root of 9 is 3. So if that was my parent function, now I'm going to graph that same pattern. So over 1 and up 1, over 4 and up 2, 1, 2, 3, 4, up 2, and over 9, up 3. So there's my transformed function. The other thing I could have done, I could have taken my parent points, gone left 1 and down 4. See, left 1 down 4, left 1 down 4, left 1 down 4. So the domain of this function is all my x values start at -1 or to the right of that. So x has to be greater than or equal to -1. My range starts down here at -4, and all the y values are greater than that. So y has to be greater than or equal to -4. This is a linear function, y equals mx plus b. So I start at -2 on the y-axis, and my slope is 1/3, up 1 over 3, up 1 over 3, down 1 over 3. And a linear function always has a domain and range of all real numbers because it continues forever in both directions. The cubic function, this is being shifted to the left by 2. And the normal cubic function goes over 1 up 1, because 1 cubed is 1, and over 2 up 8, because 2 cubed is 8. So over 1 up 1, over 2 up 8. Same in the negative direction. -1 cubed is -1, and -2 cubed is normally -8. So -1, -1, -2, -8. So this has just been shifted to the left by 2. And the domain and range of the cubic function are all real numbers. I can go out forever, and I can go up and down forever because of those arrows. So now here are the 3 strategies for graphing quadratics: vertex, standard, or intercept form. Your life will be made easier if you graph it in the form that it's in, rather than trying to convert everything into standard form, because you might make mistakes when you multiply. So an intercept form function, what you want to do is find the x-intercepts. So it's called intercept form because you can find the intercepts. -3 and +1 are the x-intercepts of this function. -3, +1. That means that the vertex of this function lies somewhere on the axis of symmetry of -1. So -1 comma something is our vertex. We're going to plug -1 into this function. So we would get 2 times -1 plus 3 is 2 times -1 minus 1 is -2. So that looks like -8 is our vertex. So -1, -8. And then this is being stretched times 2. So the normal parabola goes over 1, up 1. We want to go over 1 and up 2 this time. The normal parabola goes over 2 and up 4. We want to go over 2 and up 8, twice as steep. So this is our parabola. Number 15 is in standard form. So we do -b divided by 2a to find our x-intercept. So -2 divided by 2, because 2 times 1 is 2. So our vertex is at -1 comma something. We plug the -1 into the original function, so we'd get +1 minus 2 minus 7. So that looks like -8. So I'm at -1, -8 for my vertex. I'm a normal parent function, concavity up. So over 1, up 1, over 2, up 4, over 3, up 9. Number 16 is in vertex form, going left 4. So my vertex is at -4, and this time I'm shrinking my graph half as tall. So normally I go over 1, up 1. This time I'm only going to go up a half. Normally I go over 2, up 4. This time I'm going to go over 2 and up 2. Normally I go over 3 and up 9, so I'm going to go over 3 and up 4 and a half. Half of 9 is 4 and a half. So this has been shrunk, it's half as steep. 17 is in standard form again, so I'm going to do negative b divided by 2a. So my vertex is at 1 comma something. Plug in 1 and I get 2 minus 4 plus 1, so negative 1. 1, negative 1 is right here. Concave up with a steepness of 2, so over 1, up 2. And then I'd have to go over 2 and up 8. 1, 2, 3, 4, 5, 6, 7, 8. And then you should look at your y-intercept, because remember your c value is your y-intercept. So see, my y-intercept is at 1. Up here, my y-intercept was at negative 7. All right, what about transforming between vertex and standard form? So you need to be careful when you're foiling this out, excuse me, you want to write it out twice. So I'm going to do the 1/2 at the end. So I do x times x is x squared. My outer is 4x and my inner is 4x. So together that gives me 8x. And then 4 times 4 is 16. I need to multiply that all times 1/2. So my final answer would be 1/2 x squared plus 4x plus 8. In 19, I'm going to do FOIL first and then multiply by 2 at the end. So x times x is x squared. My outer plus my inner, so this would give me negative 1x plus 3x is positive 2x minus 3. Distribute the 2. Y equals 2x squared plus 4x minus 6 would be my final answer. So this function and this function are the same. They're just in different forms. This function and this function are the same. They're just in different forms. 20 and 21 are in standard form, and you need to put them into vertex form. So we need to find our vertex. So negative b divided by 2a. This is the vertex I just found up here, right? So my vertex was at 1 comma negative 1. So if the a value is 2, in vertex form, the a value still needs to be 2. To go right 1, I would go x minus 1 squared, and to go down 1, I would put a minus 1 outside the function. And this function right here I borrowed from number 15, and so we know its vertex was at negative 1, negative 8 from my work up above. The a value is 1, so y equals, to go to the left this time, it would be x plus 1 squared in the parentheses, and then down 8. So this function is standard form, vertex form, but it's the same function, the same graph. So here's an application problem. They've given you the function here. What is the vertex on the graph and what does it represent? It's kind of hard to tell. So what I was saying is do your negative b over 2a. So negative 140 divided by negative 1.4. Oops. So negative 140 divided by negative 1.4 is 100, comma. When I plug 100 in to my function, negative 0.7 times 100 squared plus 140 times 100. I get 7,000. Does that look like about 100, comma 7,000? It's kind of hard to tell. So what does it represent? If I sell 100 packages, I make a max profit of $7,000. What are the x-intercepts? So 0, 0 is one x-intercept, and it looks like, that looked like 200. If the vertex was at 100, then this must be at 200, right? Because it's symmetric. So it's hard to tell because it's counting by an unequal number on the bottom, but it must be at 200. So that's the break-even point, right? So I make $0 if I sell 0 or 200 packages. So actually, the more tutoring packages I sell, I start losing money, either because of the cost that I have to put in, the hours I have to put in. So we want to get that sweet spot, the vertex. What is the y-intercept? In this case, the y-intercept is just 0, 0, right? So it's just what I sell or my profit for selling 0 packages. Makes sense. If you don't sell anything, you don't make any money. It could be a negative y-intercept. So if I've invested something into my company, I might have a negative y-intercept. So if I have negative $400, it means I've invested $400. And so if I don't sell anything, I lose $400. But in this case, it was at 0, 0. Hope that has been helpful.